Tired of confusing tech jargon? Welcome to the Why Explained. We cut through the noise to decode the systems and explain the foundational principles.
Today, we're diving into one of the biggest questions out there, and honestly, it gets more complicated by the day. What is intelligence? For the longest time, we thought we were just studying ourselves. But now, with the incredible explosion of AI, we're being forced to look at that question in a completely new light.
You'd think it would be simple, right? But here's the real mystery, the one that's right at the heart of all this AI development. The smartest people in the world, the actual experts building these incredible systems, they can't agree on a single definition for intelligence. So why is something so basic, so fundamental, so incredibly hard to pin down?
And look, this isn't just some lofty academic debate. A report from the UK's House of Lords found that when they asked the experts for a definition, they got dozens of different answers. This confusion has real-world impacts on everything from how we regulate AI to how we even talk about it. If the experts are this divided, where does that leave the rest of us?
To start untangling this whole thing, we've got to look somewhere you might not expect. Not at the machines, but inside our own heads. It turns out, a huge part of the problem with defining intelligence is, well, it's us. Our brains are always on the lookout for shortcuts to make sense of the world. We call these cognitive biases, and most of the time, they're super helpful. But they can also lead to some major mistakes in judgment, especially when we're trying to wrap our heads around something as massive as intelligence. The bottom line is, we're just not as objective as we like to think. One of the most powerful of these biases is something called the anchoring effect. This is basically our tendency to give way too much weight to the very first piece of information we see. That first impression, that anchor, can totally sway everything that comes after it. And here is that bias in action, plain as day. Researchers showed a bunch of AI experts 9 different definitions of intelligence, one after another, in a fixed order. And you can see exactly what happened. The level of agreement started really high and then just steadily dropped. The experts were anchoring on those first few definitions, no matter what came next. So the researchers tried a really simple fix. They just randomized the order of the definitions, and poof! Just like that, the trend completely disappeared. The agreement levels became much more even. It's a pretty stark reminder that even for the experts, how you see information can matter a lot more than what you see. Okay, so our own biases are making this whole thing pretty tricky. Let's try to simplify. Instead of hunting for one single perfect definition, let's just try looking at intelligence in 2 different buckets, the kind we have and the kind machines have right now.
Human intelligence is incredibly flexible. I mean, think about it. When you learn to ride a bike, you're not just memorizing steps. You're getting a feel for fundamental concepts like balance and momentum, and then you can take those concepts and apply them to something new, like riding a scooter or a skateboard, without having to start all over again from square one.
Now, the AI we all use every day, Siri, Alexa, that algorithm that knows exactly what movie you want to watch next, that's what we call narrow AI. It's basically the opposite of our flexible minds. It's incredibly powerful, but only for one single specific job. An AI that's a genius at chess can't take that logic and use it to drive a car. It's a specialist, through and through, not a generalist like us.
So if they're so different, what's the connection? Is there some kind of fundamental process that both our brains and these AIs use to learn? Well, the answer is yes, and it all comes down to one core function. This is the secret ingredient. At their very core, both our biological brains and these artificial neural networks are built to do one thing really, really well: recognize patterns. Learning, for both of us, is all about finding the meaningful patterns in a giant sea of information, whether that's in images, language, or life experiences. Our brains have dedicated hardware for this job. Different parts of the brain are specialized to spot different kinds of patterns, everything from simple shapes to big abstract ideas. AI tries to mimic this structure with what we call neural networks, but it's still missing that secret sauce, our amazing ability to adapt and generalize from everything we learn. So this brings us to a really fascinating experiment. We've established that human intelligence and this narrow AI intelligence are pretty different. But what happens when you try to measure one with a tool designed for the other? What happens when you make a cutting-edge AI sit down and take a human IQ test? A group of researchers did exactly that. They took some of the most advanced AI models out there and gave them the Wechsler Adult Intelligence Scale, also known as the WISE-4. This is a gold standard, professionally administered IQ test. And the results, well, they were not what anyone expected.
So, here are the results. In two major areas, verbal comprehension and working memory, the AI scored in the 99th percentile. That means it's better than 99% of all humans. It's literally superhuman. But then, look at perceptual reasoning. That's visual logic. The AI completely fell apart, scoring in the bottom 1%.
This chart shows you exactly what that looks like. It's not a nice, smooth curve of intelligence. It's what the researchers call a spiky profile. You have these towering, almost godlike peaks of ability right next to these deep, deep valleys of complete inability. This looks nothing like a human mind.
So let's be absolutely clear. When it comes to processing language, defining words, recalling facts, holding information in its memory, these AIs are already way beyond the capabilities of the average person. Their performance is, quite literally, off the charts.
And this is a huge but. When you ask it to reason about visual patterns, to make sense of shapes and how they relate to each other, its performance just falls off a cliff. It scores worse than 99% of people. It is a staggering, mind-boggling weakness.
And this puzzle shows you the problem perfectly. It's a standard matrix reasoning question. You and I can look at this, spot the pattern pretty easily, and see that option 4 is the right answer. The top AI models, they are completely stumped. They could write you a beautiful poem about this puzzle, but they can't actually solve it.
So, what does this spiky, uneven, and totally non-human profile of intelligence actually tell us? Where do we go from here?
This right here is the crucial takeaway. We had to stop thinking about AI on some simple linear scale from dumb to smart. It's not just a lesser version of us that's playing catch-up. All the evidence is pointing to the fact that we're watching the emergence of a completely different kind of mind. So, let's just sum it all up. AI has these incredible, spiky abilities we've never seen before. It has perfect memory, but it doesn't have what we would call common sense or intuition. The best way to think about it isn't as a copy of our minds, but as something, well, something truly alien.
And this leaves us with a final, really fascinating question. For all of human history, we've only had one example of high-level intelligence to study, our own. But now, for the first time, we have a second one, and it works by totally different rules. As we continue to build this alien intelligence, what might its strange, spiky profile teach us about the hidden strengths, the weird biases, and maybe even the forgotten capabilities of our own minds? Maybe, in trying to understand the machine, we'll finally start to understand ourselves.
Now you know the why behind this concept. If you want to master the systems that run our world, hit subscribe for more foundational explanations.